Okay, this is section 4.3, quadratic functions and their properties. Now on the quadratic functions, this is the standard form where you have ax squared plus bx plus c. You need to be familiar with that form. There's another form called the vertex form, which is on another slide or two, and you need to know that one also. Now the rest of these slides actually show a lot of the information that you should already know about quadratics, like the shape of them, whether it opens up, opens down, you know, that kind of thing. So I just left them in here, even though I feel like you know those already. And I'm going to go straight to the examples and get started. Okay, so this is the one I was talking about with the vertex form. You do need to be familiar with that and know that, and we're going to get to that in one of the examples later today. All right, so we're going to begin with the examples. Example 1, graph this function. Now there's two ways to look at this. One way would be to find the, use the completing the square. But I find students struggle with that, particularly if there's something in front of the x squared. So I think the easiest way is if you remember x is equal to negative b over 2a from like algebra 1, then you can just plug in the values and go straight to that vertex and axis of symmetry. So this would be negative 6 over 2 times 3, which would give us 6 over 6, which is 1. So x equal to 1 is our axis of symmetry. And the vertex, to find that, we just plug in 1 back in the formula, which would give us 3 minus 6 plus 5. So that's 2. Okay, so 1, 2 is our vertex. Now to graph, I like to just make a table. Since our vertex point is the center point there, I'm going to pick values on either side and then plug that in and get the x's. Now the one with the 0 is probably the easiest one to figure out because you know those other ones are 0. So this would be 5, and because it's axis of symmetry, this is 5. All right, so let's see. This would be 1, 2, opens up. We have 0, 5. Remember there's a matching point over here, so it goes like this. All righty. Okay, so for example 2, without graphing, locate the vertex and axis of symmetry of the parabola defined by that. Is it concave up or concave down? Well, the first thing I'm wanting you to notice is that because this is negative, you know, a is negative 2, then I know it's concave down. So that's the easiest part right there. Then when we go to the other part, vertex and axis of symmetry, well, x is equal to negative b over 2a. So negative 8 over 2 times negative 2. So it's 8 over 4, which is 2. Okay, so my axis of symmetry is x equal to 2. And then all I have to do is plug in my 2 into my function there and solve. That would give me negative 8 plus 16 minus 3. So that's what, 5, I think? So the vertex is 2, 5. So this slide just shows you pictures. You can have 2 x-intercepts, 1 or none, whether that opens up or down. All right, so example 3 is the most challenging one I believe we have. It does take a while to get through this one because there's lots of different parts. So let's take a look at that. First thing we want to do is notice that it is going down, right? It's concave down because A is negative, so I know it's concave down. So let's find our vertex, negative b over 2a. So it's negative 4 over 2 times negative 2, so that gives me 1. Okay, so x equal to 1 is my axis of symmetry. if I plug in 1, let's see, that gives me -2 plus 4 plus 2, so it's 4. So that means my vertex is 0.14. All right, so if I make a table of values here, then I'm going to pick values on either side. So if I want 1, 4 to be the middle, this would be 0, -1, this would be 2, this would be 3. If I plug in 0, that gives me 2, so I know that that one's 2 also because it's symmetrical. I'll plug in -1, I believe we get -4. All right, so when I go to graph it, 1, 4, and then 2, 2. Okay, so it goes like this. Pretend it goes through that line. Alrighty, so let's see. Domain is going to be all real numbers, so that's from -infinity to +infinity. Now the range, notice there's a top value of 4 and then it goes down, but we have to put it in order of the number line, so -infinity to 4. We do have a bracket because it does include the 4. Now the next part is asking where is f increasing or decreasing? Well, it's increasing where it's going up, so increasing. Remember, you're always going left to right on those. So increasing from -infinity to an x value of 1, and then it's decreasing from 1 to +infinity. Now this last part is a little bit challenging because they're asking us where is f of x greater than 0, or then again less than 0. Well, it's greater than 0 everywhere in this area because everywhere it's above the x-axis. The problem comes in on this one is because we don't know exactly where it crosses the x-axis, so it's hard to give our intervals. So what we need to do is find the zeros. So this one we're going to end up having to use our quadratic formula. Of course, you could always use your completing the square, but most kids prefer this one. Completing the square for some reason is just a little bit tougher. So anyway, it's -b plus or minus square root of b squared minus 4ac all over 2a. So if you don't know the quadratic formula, that's it, because this one does not factor. It's not nice, pretty whole number points for us. So if we plug in these values, this gives us -4 plus or minus square root of 4 squared, that's 16, minus 4 times -2 times 2, that's a +16, okay, over 2 times -2. All right, so x would be -4 plus or minus, this would be 4 square root of 2, simplified, over -4. And so if we break that up to simplify it, then I get x is equal to 1 plus or minus square root of 2. Now you would think that negative is there, and it is, because it's got to be plus minus anyway. That means there's, it won't really matter which one we do first. But these are our zeros here. They're our x-intercepts, okay? That's important. So when we find where f of x is greater than 0, then we know it's everywhere in between the two. So that means it's from 1 minus the square root of 2 all the way over to 1 plus the square root of 2. It's parentheses, not brackets, because if it was at that, it would be equal to, so an f of x is less than 0 when it's below that, so from -infinity up to negative square root of 1 minus square root of 2, and then again from 1 plus the square root of 2, the x-intercept, up to infinity. Or really, I should say down, because it's going down. But anyway, so that's where it's greater than 0 or less than 0. All right, so example 4 asks us to do the same thing, but I find it's a little bit easier because it's easier to find the x-intercept, or the 0. So let's see, is it concave up or concave down? It's obviously concave up because a is positive. And to find the vertex, it's -b over 2a, so this would be -4 over 2 times 1, which gives me 2. So x equal 2 is my axis of symmetry, And if I plug in 2 into the formula, that would give us 4 minus 8 plus 4, so it's 0. So 2, 0 is my vertex. Alrighty, so let's see, they do want us to graph it. Alright, so if 2's in the middle, 1, 0, 3, 4. If I plug in 1, I get 1, which means there's a 1 here too. If I plug in 0, I get 4, which means there's a 4 here too. So when we look at that, x is 2, y is 0, 1, 1. There's a point here that matches. There's one here, so it goes like this. All right, so there's our graph. Now they want to know what's the domain. Okay, I'm going to write that up here. Domain is from negative infinity to positive infinity. There's no restrictions on x. The range is going from y of 0 up to infinity. Where is it increasing and decreasing? Well, the first part is decreasing because remember you're going left to right. So from negative infinity to an x value of 2, it's decreasing. It is increasing from 2 to infinity. And let's see, where is that greater than 0? Well, f of x is greater than 0 everywhere but 2, because that's where it'd be equal to 0. So this would be from negative infinity to 2, and then again from 2 to infinity. Where is it less than 0? That's not applicable, nowhere, none, whatever you want to call it. There's no parts that's less than 0. Okay, on number 5, they ask us to graph this one also. We're just going to kind of sketch it. Is it concave up, concave down? Well, this one is going up because A is positive right there. Find the vertex. Okay, so negative b over 2a again. We're doing this on basically every one of them, which is kind of nice. Okay, so this would be negative 1 over 2 times 3. So this is negative 1, 6. So I have to say yuck, you know, because that's a fraction. That is our axis of symmetry. They're forcing us to deal with a fraction here. We don't really get a choice. It's nice when we don't have to. All right, so if I say f of negative 1, 6, and plug that in, and you can do the math there on your calculator if you like, you get 23 over 12. Okay, so our vertex is negative 1, 6, and 23 over 12. All right, that's our vertex. All right, so when we go to graph it, and I'm just going to do a little quick sketch here. X is negative 1, 6, so just a little bit out, and almost 2, and it opens up. So I know it goes like this, right? Not pretty, but that's what it looks like. Domain is still the same thing as always, negative infinity, positive infinity. Range, let's see, it has a bottom y. So that bottom y would be, let's see. There we go, bottom y. Oh, sorry, gotta get that out the way. Okay, is 23 over 12 all the way up to infinity. Let's see, increasing, decreasing. Okay, well, it's decreasing on the first chunk, so it's decreasing from negative infinity to an x value of negative 1, 6. It's increasing from negative 1, 6 to infinity. Where is that greater than 0? Everywhere. The entire thing is greater than 0. So f of x is greater than 0 from negative infinity to positive infinity. So that's everywhere. All right, so on this one, they want us to determine the quadratic function whose vertex is negative 3, negative 7, whose y-intercept is 2. So on this one, you need to know the form of the equation. Y equal a times x minus h squared plus k. Okay, that's our vertex form. You need to just know that. You also need to know that the vertex is your h and k. So our h and k for this problem is negative 3, negative 7. Then you take the other information that they give you, which is this y-intercept is 2, and write that as an ordered pair. Okay, so that ordered pair would be 0, 2. That is our x and our y. So what we're going to do is we're going to use all that information, and we're going to find A. That's the only bit that they didn't give us. So we're going to use that to find A. So we're going to plug in Y is 2, A we don't know, X is 0, H is -3. So minus a -3 would be +3, and then K is -7. All right, so there's my equation. And I'm going to solve this by adding 7 to both sides. 3 plus 0 is 3. 3 squared is 9. So that's 9A. All right, divide by 9, I get A is 1. So once I know what A is, I can write my equation. Y is equal to 1 times X minus the -3, so +3 squared minus 7. So notice in my final answer, the H and K are values, but the X and Y have to stay X and Y. Now you don't have to put a 1 in front of your, where the A goes, unless of course it's something other than 1, but if you put it, that's absolutely fine. All right, on example 7, determine whether the quadratic function has a max or min value and then find that max or min value. Well, because this one we see A is positive, we know it opens up. If it opens up, it looks like this, right? That means that it has a minimum. It has a minimum. So to find the minimum, we just need the vertex point, or we need the Y value of the vertex. So that's -6 over 2 times 1. So that gives me 3. So X is 3 is our axis of symmetry, but I have to plug it back in. That doesn't, plug it back in the formula because I need the Y value of the vertex point. So this would be 9 minus 18 minus 3. So what's that, -12? So that means our minimum is -12. All right, last problem. Example 8. A water balloon is launched from a stadium 100 feet above the ground at an inclination of 45 degrees to the horizontal with an initial velocity of 100 feet per second. From physics, the height h of the projectile above the ground can be modeled by, and what's really nice is they gave us this formula right here, which means all of that verbiage that we just read in the problem is given to us. We don't have to interpret it. We don't have to make an equation or anything like that. All we got to do is use the equation. So that's actually very, very nice. They're asking us to find the maximum height. So remember, if this thing is getting thrown, right, the max height is the Y value of the vertex point. So that's what I need. So I'm going to find the X, -b over 2a. So that's a -1 over 2 times -32 over 100 squared. Oh, yuck. Let's see, this would be 1 over 64 over 100 squared, which would be 100 squared over 64. And if you plug that in your calculator, I believe it is 156.25 feet, okay? But remember, that's the X, okay? So this is where it is. It doesn't tell us what the actual height is. So we have to plug that in. So F of 156.25, you're going to plug that in your calculator. I believe you do get 178.125 feet. And you could double check that for me. Make sure that's what it comes up to be. Okay, so that's the max height of the projectile. The next part, how far from the base of the stadium will the water balloon hit the ground? Basically, you're looking for this x-intercept, okay, at the bottom. So x-intercept or 0 is what you need. So you could actually just use the graphing calculator here and find the 0. Find the 0 or the intercept. Unless you just really wanted to solve the equation where you'd go 0 is equal to -32 x squared over 100 squared plus x plus 100, but like who wants to do that math, right? So if you just use a calculator and solve that, find the 0, it's pretty much straightforward. All right, we have finished our notes. So we'll work on the Math Excel after, and if you have any questions, just be sure and let me know.